Hi, I'm Coco Shen, and my final ECS 475 project is a Titanic machine learning from disaster. So, our agenda today is we have an overview, exploration, data analysis, future engineering, machine learning, and closing. First, the overview of this project. This is a Kaggle computation, and the goal is to apply the tools of machine learning to predict which passengers survive the tragedy. So we know in the history there is a ship named Titanic, and it hits the iceberg and it sinks. And we want to know what some key factors like age, sex, do you have siblings or parents? Those kind of factors could predict this person's survival rate. And the submission to the Kaggle need to be the passenger ID and the survive. So there'll be two columns here. 0 means there's no survive, and 1 means they survived. So for the first part, what we do here is we're using exploration data analysis. And we want to see what the training data set and the testing data set looks like. So we can see there is 891 data of the training set, and there's 418 data of the testing set. And there are some missing data here, like the in age, cabin, and embark. There's some missing data. So first we see the age. We want to see that age have an impact on the survival rate. Yeah, from here we can see from the age 0 to around age 12. So that means the children have a higher survival rate than the adults and the elders. P class means how much money they pay for to get in which class of the ship. So we can see there is huge difference between the in the P class 3, the survival rate is much lower than the non-survival rate is much lower than the survival rate. And the P class 3 means they pay really less to get the class. And the title, so we use different title, we're grouping it in the different title to see how the survival rate is. So we can see some title like lady or the third, they might have bigger impact, but we don't know how big it is. Yeah, from gender, we could see female has much higher survival success than the male. Sibling and spouse. So for people who have siblings and spouse, their survival rate is much lower than the people who don't have sibling and spouse. For the fares factor, it means how much money they pay for the ticket, and we can see it's not much impact on the survivability here. For the cabin, so there's some missing data in the cabin category. So for the yes, that means we having the data. For no, we don't have the data. For the yes section, we can see the people have a much higher survival rate than the non-survival one. And embark, that means where the people ports. So we can see there's different port and they have different rate, but we don't know how these can impact the survivability. The next step we do is a feature engineering. First, we drop some missing data and fill in the missing data and reshape the data set. Yeah, for here we drop the missing data 12 columns, and now we have data down to 889 entries. So in the training data set, we do the label the data and also drop some according data like survive, name, and ticket. And then we use the one hot coding, so we can see there is 23 total feature of the one hot coding. And for the testing data set, we do the same, and we're also grouping the age, sibling, spouse, parents into different category, and also for the fair we did the same thing. And here we also got 23 features. And in the machine learning model part, we use the SVM, random forest, AdaBoost, and KNN. The Phantom part, we define the model framework and using the ROC score as a standard. And we define the model parameters. I tried different parameters. This is something I got, but I don't think this is optimized. And for the parameter tuning, we can see the searching time is for the AdaBoost is pretty high, it's 194. And then we define the submission model, we define how the file should look like, and also have the coding model. And then I submit. For the closing part, for this project, I think there's some room to improve. Like I keep testing the accuracy of the classifier, like using some other tools, or I can try different models like I can use a decision tree or some other tools and try the different parameters to improve the accuracy of my prediction. Thank you for listening. That's a project.